Hello, Spartans. We are in part 2 of lesson 15. So, we spent the other day, this says yesterday, it was really more, almost a week ago now, but we've observed cases where we needed to use a few different functions to tell a story. We call these groups of functions piecewise functions. Some things that we need to know about piecewise functions are: 1. Piecewise functions always come in groups of functions. 2. Piecewise functions always have their domain stated. We never assume the domain. So, long story short is I'm going to give you a few different equations, and I'm going to give you the areas in which those equations apply, just like we did in the activity today. Let's use an example. Sean wants to rent a car, all right? The rental car company requires him to pay $100 up front and an additional $50 per day. How much would it cost for Sean to rent the car for 5 days? Graph the relationship of days versus cost. So I'm going to zoom out a little bit so that we can see the whole graph with the whole problem, okay? So, Sean picks up the car, and right off the bat, they charge him $100. So from here all the way to here, they require him to pay $100 up front, and then an additional $50 per day. So, how much does he have to give him up front? Well, $100, but then he's got to pay $50 for the first day. So, his first point is going to be right here at 150, and it's going to go all the way over here to the end of the first day. Now, what happens at the end of the first day? Well, we start day 2, right? And then he has to pay another $50. So we start right here because 150 plus another 50 is 200, right? So we start there again. And then we go all the way out till we get to the end of the second day. Now, I want you to stop right here and circle here, because once I've started the second day, I have to pay that extra $50, right? And at the end of the second day, I have to pay an extra $50 for the third day. So then I'm up to $250 all the way over to the end of the third day, at which point I put a circle, and then I got to pay an additional $50 for the fourth day. All the way to the end of the fourth day, circle at the end of the fourth day, another $50 at the end of the fifth day. And here is where we get our answer for my problem. It says, how much would it cost Sean to rent the car for 5 days? Well, it would cost him, to go 5 days, it would cost him $350. Now, if he went a minute over 5 days, then we're talking 6 days, and it would be up here. But for now, it is $350 for 5 days. Okay? And look at that. Look at that. $350 for 5 days. $350 for 5 days. Just had to double check my work. Okay? Notice some things about this. I'm going to do this in green. Notice the dot here, and notice the circle here. Remember, as soon as the clock strikes midnight, we're in a second day. Meaning, another $50 gets charged. Midnight hits, another $50 gets charged. Midnight hits, another $50 gets charged. Midnight hits, another $50 gets charged. Does that make sense? That's why you want to turn in your rental car in on time. Okay? Now, is this a function? Well, it is. It is. The things to notice about this function. notice the circles and dots. What do I mean by that? Well, if this was a dot right here, I am in this area right here. If that was a dot and not a circle, what would that mean? That would mean at the end of the first day, I'm paying both $150. I'm paying both $150. I keep erasing my thing. I'm paying both $150 right there, and I'm paying $200 right here. So I'm paying two things at once. Is that possible for this to be a function? It's not possible. So it has to be a circle there when there's a dot right there. It could have been like this. It could have been a line with a dot here and then a circle up here. Keep going. I should do that in a different color so as not to confuse you. Don't write this down. I just want you to see this. I could have had, and I'll do it in green, I could have had a dot right there and then a circle right there to keep going. But this particular problem didn't take that into account, so I don't want you to worry about that right now. But the thing I do want you to worry about is we're going to institute a new test. And this is how to figure out if something is a function in a graph. And we're going to call it the vertical line test. Notice how I just drew a vertical line up there. I'm going to go back to my regular zoom. Okay, now I'm going to play with this vertical line and look at how many times the vertical line crosses my function. It's not crossing at all over here because I'm not in a domain. But here, as soon as I'm in a domain, I'm crossing a line, aren't I? Now, how many lines am I crossing? Let me erase this dot right there. How many lines am I crossing right now? I am crossing only one line. Now, when I get to the dot, notice I'm crossing 2 points, but what does that circle mean here? What does this circle mean right there? It means that the line can approach that point, but it can never be on that point. That's why I do a dot there, or a circle there, I'm sorry. But I got a dot up here. So it's only crossing one point at this point, and it's right here. And then I keep going, and I'm crossing one line, and to another point again. But look at circle. It's not crossing there because it doesn't exist there. I just draw a circle to show that that's where it ends. But it does cross right there, only one place. Now, if I had where it crosses two lines at once, we can tell right there that that is not a function because it crosses here and here. So that would not be a function. But because this crosses at only one place, this is a function. Okay? So, vertical, well, I don't want to do that in green. I want to do that in black. Vertical line test. And that's how we check for functionality in graphs. Thank you for your time, ladies and gentlemen.